All right. Chapter 11 this week won't actually be too bad. There's not too much here. There's a lot of fun things we can do with this in terms of looking at the material in Zybooks. It's not so much there, but we're going to use these abstract data types, the stuff that's built into the library for us, to do more fun things. So that's sort of the idea with the container. So we've used vectors already. That's one of these that we've used before. There's other cool things we can do with pairs, maps, sets, queues. This is pronounced deck, apparently. I don't know why or who came up with that, but that's how we pronounce it. So with Q, you get 4 silent letters, the UE, UE. And with deck, you get just the UE is silent. Because the Q also makes a K sound, apparently. I don't know. English is crazy. And then finding and sorting are super fun. So being able to find something in a abstract data type, in this collection, just this way of how do we hold data. That's sort of the idea here. So we've done for loops before. This one's not super interesting, right? Where we loop through things, and we've done this little enhanced for loop with a colon. Sorry, that's a little small here. Wow, it might be too big. Right, so we've done loops like that. Excuse me. So regular loops using index, range-based for loops, just looping over the collection. Not too much different here. Right? These should be pretty familiar when we've been using vectors, but nothing super new with those ones. Now, you got to be careful when you're using the values, though, right? That we don't try and modify them. Right? If you want to be modifying them, we want to be using the references. Right? You got to make sure we're saying, hey, I want the reference for this value as we're looping through it here. Just like when you pass values to functions, right? We would get copies. When you do the enhanced for loop here, the range-based loop, you'd get copies. So it's one way around that. So we can use the reference, say, if we want to go and change these things. So a pretty common one. And I always like to be a little silly about this one because everyone likes to ask for a curve for grades. But I don't think anyone actually wants a curve, right? So we'll look at what that looks like here in just a second. This is, what week are we on here? Week 6. Containers. So a standard curve, deviation curve, probably something like this one here. Right? This would be a curve. So if you ask for your grades to be curved, what you're asking for is to have the highest number of grades right smack dab in the middle. It's probably a C, right? And then smaller percentage getting a B, very few people getting an A, right? That's not what people want, right? What they want is just typically the highest score, difference between that and 100%. They want that number added to everyone's score, but they call it a curve. That's not curving scores though, right? That doesn't fit them to a curve here. So just, you gotta be careful with words sometimes. All right, so let me get rid of some of these. So we can look at that quick example here. So why don't we build a quick little loop here. So maybe we'll say, here's an int for, score is, let's go with 0. And maybe while score is not -1, because -1 is probably not a valid score here, right? And we'll throw all these in a vector. Vector of int scores. So we can include vector. Is that going to type it for me? Yeah, there we go. And using namespace standard. Right. We'll ask for the score. Enter a score. And we can see in the score, or -1 to stop, and then we can push it back into the vector. Now, it's not actually great because we would add a -1. That's the one downside of doing it this way, right, with the loop. So one more check if score does not equal -1, which is a little sad. We could add it, right? Or we could put this up at the top, but then we're going to add a 0, right? There's not a lot of great ways. So a little bit of extra typing here is not the end of the world. I feel a little bad having the same thing twice, but it'll be okay. Right? So after we have all the scores, then, right, we want to find what the highest score is, right? And we want to find out the difference between that and 100. We could do that while we're entering the scores if we wanted, right? Or we could do a quick loop, right? We could have an int highest score. That's going to be our scores at probably 0, right? Until we know otherwise. We'll assume the first score is the highest, and then we can loop through. So for int score and scores. Now we don't need the references here because we're not changing anything, right? We're just reading the values back out. So it's perfectly fine. We could get references, but we don't need them here. And say, hey, if my score is higher than the highest score, right, I have a new highest score. Hopefully this is nothing new and exciting. Right. Once we're done with that, then I need to find the difference. Right, so my difference is going to be 100 minus the highest score. And then if you want to go through and add that to all of the scores to say, okay, if an 82 was the highest score, but we're going to count that as 100, everyone else should get 18 points added to their score, right? I don't know where that became the norm or why that started happening. I blame chemistry, probably. I'm not exactly sure, but I hear about this happening way too often. People are like, oh yeah, the best score was a 70, so everybody got 30 points added. I don't know, it feels like something else is wrong there, but that's okay. So if we want to modify our scores, right, we can get the reference here as we loop through. Then I can take the score plus the difference, and it'll actually have been changed inside the vector, right? If we don't include the reference, use the scores in the vector won't change, right? So if we run that in debug mode, we should be able to watch these change as we go here. So throw out some scores here that we can add, but not 100, right? Because we want to make sure they actually do change. So how are you guys going to do on the midterm? Is that a mean question? Just throw out some scores. It's okay.
87.
87, all right. 90? How about one more?
92.
And a 92. Okay, so the highest there then should be 92, right? So we should be adding 8 to all of them when we loop through, right? We calculated the difference was 8. Looks good so far. Our scores has 87, 90, 92. As we loop through, we see, hey, that one got changed. Right, again, it's highlighting in red anything that changes, which is super handy in the debugger. Now at 98, and now 100. Now everyone's happy. They got A's instead of a B plus and an A minus, right? Everyone's much happier with their scores. And we did not curve them, right? You know, just be careful. Like, you don't want your scores fitted to a curve. That's bad news for everyone. So I did hear at one point, apparently, if too many people in the class get an A, it's a bad thing. But I think that's like, if everyone in the class gets an A, essentially, it's a bad thing. Because, let's just be honest, like, not everyone's going to do all the work. So it's very unusual when they look at grade distributions for like everyone in the class to get an A. Something seems a little off there, right? It's okay if most people get an A. I don't get in trouble for that. But if everyone gets an A, they start looking at me funny. Like, are you even grading things, Eric? So just that's also a fun fact. Grade inflation is another interesting issue, but that's a whole other story. All right, so looping through, right, we can use references if we want. Let me go ahead and stop that. To modify values. So I don't think we've done the reference modification before, right, where we've actually looped through. I think that was new. You might have looked it up if you found it before, but anytime we've done these little for loops, essentially say they're read-only. But now you can get them out by reference if you want. And you can even use auto if you like auto, which is fun. So you don't have to type the variable names here. All right, cool. So that's our little loops there. Wow, that's too large now. All right, a pair is a really fun data type. I like pairs. So the idea with pair is this one comes from the utility library. So a pair gives you two things. You have a first and a second. So we're going to say these two things come in a pair. You get a first type of data and a second type of data. And it can be any type that you want here. So if we wanted to, let's go include utility. Utility, nope, utility. There we go. I can make a pair Now, just having scores is fine, but maybe we want to associate some names with them. So what if we wanted to have a pair of string and maybe double? This might be Eric's score. Now to get at them though, so Eric's score dot, you have first and you have second. So I can assign first, right? As long as I give it a string, it's happy. Here's the first thing in the pair, right? I'll give it a string. And then I can take Eric's score dot second, and I can give it some sort of double here, probably 99.9, right? Can't give 100% because that'll look funny. No A pluses. But 99.9 is probably close enough, right? So you can access essentially these values in pairs, right? We're saying this value belongs with this value. Sort of a cheap way of not having to write a class that has an attribute for name and an attribute for score, right? And then if you want to get silly, you can say, hey, I want a vector of type pair of type string, comma double. And this will be my, I don't know, grades, right? So you can start mixing and matching these abstract data types because a pair of something is a type of itself. So you can have a vector of that type. So now it's not a two-dimensional vector, it's just a list of pairs, essentially. Right? And I can start adding as many of those as I want. So I can take grades.pushback, I will push back a string and a double. Right? I don't think inline gets a little funny. So I think I would probably do my pair first. So we do Jeb score. So pair of string, double, Jeb score dot first for Jeb, and Jeb score, make sure I hit the right key there, second, 92.3, and then we can push back Jeb score. Right, so we can start making a collection of another type. This is where these get to be a lot of fun. Now again, I think you're probably okay with a single pair. Probably going to be okay, right? Because we can figure out first and second. But if you need to have more attributes than that, right, we probably want to use the class and write a class for it, and we can have named attributes. Because having to remember what first is and having to remember what second is a little bit obnoxious, but it's super flexible, and then you don't have to write a bunch more class code just to deal with that. So pairs are pretty common way that you can go and use these things. So here's a pair of string and ints for the ka pair. I wish they would type out their variable names. That's my one dislike of Zybooks here. Like, just type out California. It's not hard. But okay. So population of California. Right, we get out first and we get out second. So we can get these values out. That's a pair. The next thing we can do is we can make a map. Maps are super fun. So maps give us a distinct set of keys. So a lot of times I like to think of maps like a dictionary. You'll have the key is the word, and the value associated is the definition. You're not going to have the same word in there more than once. You'll just have multiple definitions, right? So it's a little weird in that before we've never really ran into this unique set of keys before. Right? With a vector, I can throw in Eric 50 times, and it will take 50 entries for Eric because it's positional. Right? The first thing is the first thing, the second thing is the second thing, the third thing is the third thing. With a map, there's no really order. There's no guarantee of the order. It's not an order-based type here. It's just a key value pairing here. So we would associate values in our map, which is really cool. So let's include map. So if we're going to do a map and we wanted to make sure we had unique values, I probably wouldn't want to use name, because when I went to school, there were like always 3 other Erics in my class. Thankfully, that hasn't happened as much now that I've gotten older. That Eric is no longer such a common name, which is sad because it's a great name, but that's okay. So probably wouldn't want to do it just off, or at least just off a first name. But if your name was John Smith, even first and last name is probably still not very unique, right? So what sort of unique identifiers do we have for you folks here at school? Do you have a unique identifier that's not your name? Yeah, you have your student ID. So maybe we would have the key being your student ID number. So we might set up a map of, now this looks crazy now, right? I just type in map and it's a bunch of stuff here. We don't need to use all of it. Just say, okay, so we're gonna have a map of int, and what's the next type then? So maybe int and, well, what other information do we want about you here then? Well, what if we did a map of a pair of string and string? So this will be our student list, maybe? So my student list, right? And then we were going to at a value. Now this is where it gets weird because you can update or assign, right? When you do this here. So, I'm sorry, no, in place. In place will map that. Sorry, at will just assign a new value. So we use mplace to add a key to it. So if the key doesn't exist, it adds it. If it does exist, it ignores it. Because this idea that our keys have to be unique. So if you've already emplaced a key, it's going to ignore what we're doing. So we can say emplace. So the first thing we need to give it is the ID number, right? So where is the ID here for this? So let's say it's student 123. So we're going to emplace for 123. Right? And then we want to give you, well, what's the associated value? Right? Okay, well, the associated value then is going to be a pair of string, string. So we set up a pair of string, 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 and string. This is Eric here. And then we can have Eric.first, Eric Chinesky, and Eric.second. What should we do, like major? Would that be a fun one here? So maybe we'll have this pair of what your name is and what your major is. Again, probably using a class here would be really nice, but we're just trying to have a lot of fun with string here. So I'd give it the pair after that. So this is going to add to the map here the key of 123, and the value associated with that will be the pair here, which has my string for name and string for major. Okay, then you can get values back out here by using the at notation. So at will give you the associated value. Right? So we can see out and say Eric's name is, so we want our student list at 123.first. And we just sort of chain these things together, right? So if I put a pair in, this one gives me the pair, and then first gives me the first value of that pair, right? And then maybe we'll do one more. Order name is, and major is, students.at. Oh man, this is getting long here. That's all right. .second. Right, so we can throw in a lot of these. Have some fun with it. That's using a map type. So other things we can do with our map then, student list dot. Well, how do we know if there's a value there, right? Like if I wanted to update Eric here, I can't emplace because it's just going to ignore it here. I could do at, right? So I can say Eric at 123. We can assign a new value, right? Maybe we set up a new pair here. So I don't know, Eric update. Let's do that. We'll call it Eric 2 because there's a lot of Erics. First, Eric 2, and second is something about AI because AI is really fun, right? Maybe Eric 2 studying AI. So I can go and update this way, add to access or update, which feels pretty familiar, right? We were working with vectors. We could get the value out with at notation, or we could update the value with at notation, right? But if I typoed this here and I had 122, Think it's going to like that? We try and use at. Let's see, so -1 to stop our score. So we'll do 1 and -1. Oh, sorry, I had a breakpoint. Take out the breakpoint here. Oh, out of range. Right, we tried to get at a key that didn't exist. Right, well, that was no fun. Let's see. I wanted it to not. I wanted it to like break here. We'll pause here so you can see it break. 1. Come on, 1, -1. All right, we're gonna get to this line and when we run it, now it breaks. Right? In our out of range exception, so you gotta be careful trying to get at things that may or may not exist. Right? Like our vectors though, right? If we try to access an index that didn't exist, sorry, I should put that on quiet. It's not gonna work. So it's probably a good thing. We just wanna be careful and if we want to be updating a lot of different values in a map, because they don't really go sequentially, right? There's no, hey, let's access the, from the beginning to the end of the range here. You've got to know what the keys are. It's a little trickier, right? And that's where we get to find it a little bit is going to be helpful because we can see if there's a value in there or not. Yep, so figuring out if a key exists, you can use count. So we can say, where did it go here? Yeah, so use count to see how many times that value exists in the dictionary or in the map. Sorry, it's called a dictionary in other languages. So you can emplace, you can at, you can count for a given key, you can erase a key, or you can clear all of your entries. Are some pretty common ways for us to do this. Right? So count is pretty quick for us to say, hey, if my student list.count 122 not equal 0, right? Then we can go and update here. And again, probably that should be a variable name somewhere, right? If you're using it more than once, right? It's just a little weird to have a hard-coded value in there. Yeah.
Could you use it like a boolean as well? Like set it to a boolean because they said it only returns 0 or 1.
So like. Okay, because those will equal true or false. Yeah, yeah. So we can say if, yeah, I guess just if it's 1, it'd be true. If it's 0, it's false. Yeah, I like that. I think that would work for us. Should we try it? Let's see. Don't want that code. I hit run. So 1, -1. All right, so it's going to see if we get back a count here. We don't get back a count. Yeah, life is good. Thank you. That does save us a little extra code here. So if there's a count, fantastic. Now, generally you'd assume count is going to give you like the number of times that occurs. But what's fun here is because we know that these have to be unique values, it's a set here, it's only ever 1. There's never a count of 2 or count of 3 or count of 4, right? Because you can only ever have one key in there. Right? Because if you tried to add another one, it ignores it within place. Or if you try and set it, it just sets. Right? So those are pretty handy. So we can make maps of values. Right? So maps are super common because that gives us a way to store things quickly by index. Now we haven't looked at how fast maps are, but maps are actually really quick behind the scenes. They're a fantastic data structure. So later on, we start talking about how fast things are. We'll talk about how awesome maps are because they're super fast. We won't write our own because it's a small pain in the butt, but they're really good. All right, so maps are cool. Fun things with maps. A set is just a bunch of unique elements. So rather than like a vector gives me the list where I can just add things as many times as I want, it's almost like a map with no associated values. If that makes any sense, right? It's just the unique set of values here. So with a set, where's our list of functions here? You can insert, you can erase, you can count, you get 1 or 0, and you can figure out how many numbers are in the set. Wow, are they doing chess players now? That's a fun example. That's cool. Magnus Carlsen is no longer the world chess champion. The chess world is sad, but he got bored of it. He's still the best chess player in the world, but he didn't want to defend his title for world chess champion. So I think it's Ding Liren is the current world chess champion. Nakamura is like number 2 in the United States. He's a lot of fun. He streams on Twitch too. That's your fun fact for the day. Carlson will stream sometimes. And Vishy Anand is one of the tops, but no longer the best chess player. He's a former world chess champion. Oh, Fischer, he's really old. He was a really good chess player too. You wanted all these fun chess facts, right? All right, so if we want to use a set, we can go and include our set here. So this is just include set. So it's kind of fun. Like map, it just comes by itself. So we can include set. Now a set then is just going to have a single type. So a set of what type? Okay, so maybe a set of string for names. Right, and we would add our different values here. Oh, sorry. Insert, right? If you want to insert one, right? Again, look at that common list here. This is a little bit nicer of a format to look at it. You can erase a value. You can count, or you can get the size. How many items are in our set? So this just lets us have a unique set. Now, order is not guaranteed when we have a set, which is a little sad here. So if we just add a bunch of names, so if I add all my kids here, so we're going to insert Joy, insert Jeb, insert. Her name's actually Genevieve, but she goes by Vivi. But if I don't put it in, they don't look like they're all J's for fun. Insert Journey, names.insert Jubilee, names insert Jackson, and insert Jasper. All right, I got a bunch of kids. So if I want to loop through all of them, I can have a string for name in names. Right? I can still loop through it, which is fun. I can use this range-based loop over a set. Let's see out the name and end line. End line, there we go. Let's give it a quick run. Oh, I got to take out the breakpoints here. Take out the breakpoints. There it goes. Did I stop it? Where'd it go? There it is. Oops, that was bad. I gave it a -1, so I didn't have an index there, sorry, for our first value. I should have just put the code at the end. 1, -1. That's not the order I put them in, right? I remember it's not the order I put them in because that's in age order, right? But I added that one last, I added this one second, this one third, fourth, Joy was in first, Jubilee was in fifth. Like, so the order is not guaranteed when you work with sets. This is just your warning here because it's not a list, right? Like our vector is a list. The first thing is the first thing, the second thing is the second thing, the third thing is the third thing. With the set, we don't have that. So there's no order guaranteed with sets. Right? Same idea with maps as well. You don't get any order guaranteed with maps once you put things in. Like when you access them back out, that's just all we get here. Now, do you think we could loop over our student list map? Can we try that? Let's see. So let's do. All right, here let's fix this up. So if the student at 122 is not there, let's emplace a new one. Student list.emplace 122 and error 2. So if it is there, we'll update. If it's not there, we'll add. Right? It's a little helper here. So could I say for about auto student in my student list? What do you think? What type is student here? We used the auto keyword, but what actually is a student here if we're going to loop through all the students in the student list?
Yeah.
A pair, yeah. So I can have student dot first and student dot second, right? Because it's the associated value here, right? So we made a student list. We're looping through the associated values, which is fun. So we're not getting out the keys though, which is a little weird. So all we get is the values, right? So if that key was important, I don't have the key when I do this list, when I do this loop through it here, right? Because we're just getting out the student, the pair here. Right, so that was first and student dot second. And an end line. Maybe a space here, right? There we go. Oops. No? See out. Wondering why it is looking at me like I was crazy. See out? Is it not? No? We got see out the first. It's fine. The space doesn't like doing second. Oh, stream. Character and a pair of string. Huh. Knows that's a pair of string. Why is it not letting me see out? Doesn't like that one either. Doesn't like second. I'm really confused. The second stored value is a string. No operator matches the operands. O stream. I did say, I feel like Visual Studio is just being dumb here. I wonder if it'll actually run. If I hit run, no? Okay. No operator matches these operands. Wow. Oh, it's not just the, I get, okay. Yep. So it's not just the pair. I can't read right here. I've not had enough coffee yet. So auto student, if I hover over this, it's a little small here. It's a pair of int and then a pair of string. So I'm getting back the key and the value as a pair in the map. Right? And that value was another pair. So this one had a first. Oh goodness. That looks really fun, right? Second. So student.first is going to be the ID here. This is the key in the map. Second is the value associated with the map, which is a pair of string. So then I have another pair inside of here. This is why the auto is really nice. Trying to write that out seems like it'd be really obnoxious. Having to say, hey, this is a pair of int, comma, pair of string. That'd have been a little more clear though. Is that better than auto? And now it kind of makes a little more sense what we're looking at here, why we have a second.second and second.first, but it starts to get a little messy, right? But we can loop through. So you can loop through your maps, right? You can loop through your sets. Man, it's too early for all of this. All right, queues. Queues are really fun. We're going to get to queues, stacks and queues. Wow, not till week 12. It'll be a little while. We'll get there. We're going to do recursion, templates, linked lists, then we do stacks and queues. So we're going to write our own queue class when we get there, when we talk about stacks and queues. There's one built in. The built-in one is better than one we're going to write. Let's just be honest, because the fine folks here are really smart. Lots of other really smart people have looked at it and optimized the crap out of it because it's important that this stuff runs fast. We're just going to play with it, kind of build one from scratch so we can appreciate why it works the way that it does here. I think that makes a little bit of sense, right? We kind of play with these things, understand a little bit better. Your friends in engineering will probably build an engine at some point. You're not going to want to drive the car that has an engine they built, though, right? As an engineering student, you want the ones that the professionals have built and designed. Yeah. Same with us, right? No one's going to use our queue class. We're going to build it for the learning experience of learning how to build a queue. So a queue is fun in that it is restricting the access that you have to it. So a queue is a very particular data structure. You're probably familiar with them. None of you are British, right? But in England, they call lines queues. So you get in the line at the grocery store, you get in the queue. That's what a queue is. It's a line. So the lines work in that the person at the front of the line goes next. When you get in the line, you enter at the back of the line, right? Unless you're at Cedar Point and you pay extra money to get your, what do they call them now? They're not fast passes. Lightning passes, what do they call them? To let you skip ahead to the line. Generally, lines are low. You get in the back of the line, the person in the front of the line goes, right? So it's a first in, first out, or last in, last out sort of data structure. So it's built right in. So we're going to, where's our include for that one? Does it include queue? Why did it not tell me what the, oh yeah, include queue. There it is. I just didn't see it. So we can include a queue, include the queue class from our library here. And when we have a queue, so we're going to make a queue of a given type. What do you want to throw in here? Should we do scores? We've done a lot of scores, but that's okay. Let's do a queue event for scores. So scores dot, you can push back. Hey, we push back on vectors, right? You do that. You can get the beginning. You can at. Oh, it's a little improper to use at on a queue, but it lets you, because why not? Fun things like that. So let's go get our, let's add some values here. So how about we just loop through? So let's say for int score is, I don't know, should we do 70? Score is less than 100. Score plus plus, and we'll take our scores and we'll push back a score. So we'll add a bunch of scores to it here. Right, in the queue. Now, you should be able to push, pop, and front back in size. So instead of having to push back, I should just be able to do push, but it doesn't let me. That one's sad. Generally, you deal with push, pop, front. Also get what's at the back of the queue, depends. That one's a little odd here. But it's okay. So pushing to the back, we'll add to the queue. Right? Getting the item off the front here. So we're going to take our scores and we want to, we don't want begin here. That's the iterator. Place back. We want the front. Here it is. Here's our front. We get the value at the front. So this is what's at the front of the queue. Scores.front. You can say front of the line of the queue. Scores.front. Right, so it should be the first one we put in here. It should be 70. Right? Because that was the first one. So first in, first out. Why do we not get, we have front. Huh. That's fun. Uh-oh. Oh, that's why. I'm sorry. I've already called this scores. So here's my scores queue. That's probably why this one was all upset here. Scores queue. Dot. There. Okay. Now we have push. Now it's much happier instead of push back. My bad. I was trying to use the same name twice. All right. So now we get the front value. One. We'll stop. Uh-oh. Front of the queue is 100. You got the score? Shouldn't have even had 100. How did it get 100? None of those should have been 100. Now I'm really confused. Oh, I forgot to rename again. I'm using the scores vector. Yeah, not my scores queue. This is why we run our code, right? This is obviously on purpose. This will happen to you when you're running your programs, right? Be confused by what's happening. All right, we get front of the queue 70. Like we expected. So finally it's working. We got the first thing in. And now maybe we want to say, while my scores queue, make sure I use the right one here. Come on, scores queue. Where's size? Size is not 0. You can see out, here's my scores queue, pop. So pop will take off the item, right? So we're going to push, which adds it to the back. We're going to pop, which removes the front. You can look at the front, you can look at the back, or get the size. So this will get all the items back out of the queue here. Really? Another one of these? I can't pop an int. Wow.
Isn't it because if it takes it out, like you're trying to like type out what it's like taking out?
It should be give me the. Yeah, it just removes it. Yep. It just removes. So I'd have to get the front first, and then I can pop it out. Thank you. Front. Then I can take my scores queue. Dot pop. Why does pop not give it back? That's obnoxious. We'll just remove it. So get the value and then remove it. Get the value and remove it. Get the value and remove it. Eventually our size will be 0. This is not going to be in any interesting order here because it's the order that we put them in. First in, first out. We get all the values. That was not super interesting, sorry. But queues are a lot of fun because we can do interesting things with them. So if the problem that we're modeling has a form of a queue, a queue could make sense. So if you give someone a vector and you're like, hey, I'm going to treat this as a queue, you can go get it stuff in the middle. And sometimes you're not allowed to do that, right? Just kind of depends on what problem we're modeling here. So I like to imagine McDonald's, right? And they pre-cook a bunch of burgers at lunchtime, a bunch of food, and they just throw them down that chute here. So there's like a bunch of McDoubles waiting in that chute here. When you order McDouble, they just grab the one off the front because it's in a queue, right? As they cook them, they throw them in the little queue here, the line of them, they down the little slider here, and when people order them, they just pull them off and put them in your bag, and they're hot and not super fresh. But, you know, they go through them quick enough, right? Probably do. Now, you could probably grab the second one in line because you can, but you shouldn't be doing that, right? Because you want to make sure we're serving the oldest one first. That's the one at the front of the queue. So just depending on what we're modeling here, we can use queue structures to help us solve those problems. Right? Not everything needs to be a queue, but it could be. Right? Or if we're imagining like we want to run a drive-through, right? Cars will get into lines, right, into the queue here. We'll get their order and serve their food. We'll get their order and serve their food. I'm an old enough person, I remember that they didn't used to have all the like extra windows along in the drive-through. Now they figured out if they have a window that you pay at and then you have the window where you pick up your food, it's faster. Right? So they're like sort of serving people in the middle of this line instead of you order your food and then you pay for your food and you get your food. That's a very serial process. Turns out that's kind of slow. Right? If you can only ever interact with the person at the front of the queue, right, everything slows down. So the fine folks at McDonald's realized, hey, if we add a second window to all of our buildings, we can have someone taking money while someone gives the food out, and things go faster here, right? Because that was a bottleneck. So just you do see queues in the real world, and it's kind of interesting when we run into them here. Another really common usage for queues is messaging. So when you deal with messaging, a lot of times messages will get sent into a queue and you have to process them. And that processes them in the order in which they were sent. Right? And you only ever want to grab the front message. You don't want to jump ahead and get a different message out as we're going here. So a queue is pretty common structure for messaging as well, and things that we run into there. And does not work well with the vector. Right? We haven't really talked about the speed of things before yet. But remember, with the vector, getting something off or having to remember where it was, like, it's tricky to remove things from a vector, right? We haven't really even gone through and removed anything from a vector, have we? I don't think we've done that yet. And it's been a long time working with vectors. Where like the queue here, the sets, the maps, right? Being able to remove items. Sorry, that's my sugar. Oh dear, it's too high. Being able to remove things is pretty handy. If we've processed this item or we're done with it here, it'd be nice to just take it out of our structure so we're done with it. You can do it with a vector. It's not the worst thing in the world, but it's a little bit awkward sometimes to remove stuff from vectors. So these structures that are a little bit more mutable, a little more flexible, let us add and remove from, can be a little friendlier to work with. All right, that's it for Q. Q's fun. And then the last one here is dec, or DQ, but then you're going to want ice cream. So dec here. So we can include dec, so you get, essentially it's a double-ended Q, where you can add to the front or add to the back. You can take from the front or you can take from the back. That's kind of a specialty one here. So let's see if we can include dec. Include, nope, here we go, there's a U in there, dec. So we can make a deck of, we'll do a deck of strings. And we'll put a bunch of cars in our cars. We can add some cars to it here. So you can to push to the front or push to the back. So you can add someone to the front of the line, or you can add them to the back of the line, right, as we're going here. Or we can take something off the front, right? We can pop the front, or we can pop the back as we're going here. So this one might be nice. I mean, technically, you can get out of line if you're in the middle of the line, but more often than not, it's the last person in line who like pulls up at the drive-thru McDonald's and then decides, no, the line's too long, and bails. If we just had a regular queue, there'd be no way to get that car out of the queue after they decide the line was too long, right? But we could add them to the queue and then take them off from the back here when they decide it's too long, if we used a deck, right? Because we've got access to both here. We'll push front. And again, like, you could do other interesting things here. So maybe we have a string for the car, and then maybe maybe this is a pair here. So we have a pair of string for the car, and then maybe a vector of string. Well, it'll be their order. Am I missing? What was it here? We got too many. There we go. 3 sets of braces here. So a deck of pairs of strings of vectors of strings. Oh, goodness. What we're going to have is a pair, so we'll have the car, right, however we're going to identify the car, and then their list of strings, whatever they wanted to order here. Right, so we can push back. We'll need a pair. Now, make pair is a nice little shortcut here. I can make pair, and I can give it the value. Is it, I give it the values, right? Make pair. I think I give it the values here. Is it, I don't know. So here's my bolt, and then vector of string. Oh my goodness, this is going to be too long here to use even make pair. Okay, so we need an order, vector of string for the order, order.pushback. What do you guys order at McDonald's? What should we get? We're going to do McDonald's run real quick. We got 10 more minutes for the breakfast menu, right? No? No McDonald's fans? That's okay. A cheeseburger. Order that pushback. And what about a Coke Zero? Order a Coke Zero. So we'll make a pair of bolt and order. So make pair is fun, just a shortcut, so you don't have to set up the pair individually and like then reference that pair. Make pair is our shortcut for making pairs. Hopefully that one's clear. So we're going to add that pair then, right, to our cars queue. Great. That's fine. Now we can add as many cars as we wanted, right? So now when we want to loop through, right, we could grab that value at the front. Welcome to McDonald's, may take your order, get their order, have them pay for it, right? Send them on up, get their food, take them out of the queue, and work all of our cars. So we could be looping through all these items here, but it's mutable. So as we add them and subtract from them, we can add cars, take cars out. Here we'll have whatever our current state is for our queue of cars. Right? If we only had the vector here, it'd be a little trickier to work with. And now, like, vectors can have any of these other types as well. If you want to make a list of these other things, you can make a list of these other things. Right? So like when we were trying to say, hey, let's have pairs of pairs and things, you can have vectors of pairs. Right? You can have vectors of sets. You can have sets of, like, you can get a little crazy with combining all these things together. Again, once you've gone, like, just like with two-dimensional arrays, 2 dimensions we can generally think of. You can sort of handle 3 if you're thinking hard enough about it here. Beyond that, it's crazy, and you should just use a class. Because it gives us better names to things here, is really the advantage for that. And then it's worth all the extra typing. All right, we're sort of blitzing through all these fun things here. Just lots of different things. We'll play with them in lab today. Have a chance to play with some of these things. Find is a super fun function. Should we leave that for Thursday or talk about find today? I'm open for either. What do you folks want to do? Today? Sure, we'll talk about find. Oh, maybe we will. Refresh the page. We jinxed it. Really? Containers, find. There it goes. Okay, that worked. So find, we're going to want to include algorithm on our list here of includes. So the deal with finding something is you tell it where to start looking at the beginning, where to start looking at the end, where to stop looking. So you can find within subsets if you want to. Generally, we want to find in the entire collection here, but if you want to subset it, you can. It can get pretty interesting here. And these are specific to, these are iterators for where's the first and iterators for where's the last. Which sounds a little funny here, but if you remember looking way back at, say, scores.begin, like, where's it? So scores is my vector, and begin is a constant iterator. Right? When we read this nonsense out here, inline of a vector int, it's a constant oops, I can't click there apparently. Constant iterator. So this is the iterator for the beginning point. This is the beginning of the vector. So if I want to find something here, so I can say, this is my scores.find. Nope, sorry, I want to find, I would need my iterator for the first value. So I'm going to find, this is scores.beginning. Begin parentheses, there we go, and scores.end parentheses. And what value do I want to find in my score? Say we wanted to find, what do we have, 100? I think we had it in there, right? Because we bumped all of them up eventually. So you should be able to find the 100 here. Right? So searching scores from the beginning to the end for the value 100. Then it's going to give me back an iterator, which is super crazy. So I'm going to get an iterator here for where that value is, or if it's the end, I didn't find it. So working through it, it's a little funky here. So I'm going to have, auto is pretty handy for this sort of thing, or you can say, hey, the list of string : iterator is what will be the result of find. A little messy here, but say like auto, here's the, I don't know, location of 100 is find. And now this one is a vector of int iterator. This shows me where the position is that this value is here. And then if the location of 100 is equal to scores.end, we didn't find it. It was not found in scores. So if the iterator went all the way from the beginning, got all the way to the end, we didn't find it. So the ending position here for this iterator is actually beyond the end of the list. It's after all the values have gone, right? If it is at a value, it's not the end iterator here, which is a little weird. Otherwise, you can say, hey, we did find it in the list here, right? So we can find it. Find if gives you a way to give it a particular function, which is a little funny here. So when you do find if, we give it a function here. This is going to be its own headache. We'll have to come back for this on Thursday for sure. We can talk about it a little bit. So the is formatted num is the name of a function here that takes a string here. So the find if says, hey, go from the beginning of this vector to the end of this vector, find if this thing gives me back a true or false. So if this thing gives me back a true, I'm going to be found here. So this will return a true or false. Right? It either returns the false value or true value. Apparently it's only true if it's 4 digits and it's 0, 1. My goodness, what even? If it's a digit and a digit and a digit. So if 0 and 1 are digits, and then 2 is a decimal, and then 3 is a digit. Right? Should be these two, I'd expect, right? We have digit, digit, dot, digit. That's kind of messy here. But we'd say, okay, we would find the first one then, and you will dereference your iterator. This iterator is essentially a pointer. This gets super fun. So if we found the value, right, it was not found in scores. Now, trying to dereference this and say, hey, I found 100 is kind of silly because I just asked for 100. Right? So with like a regular find, it's not super useful because you knew what value it was anyway. But the find if might make a little bit more sense to dereference your iterator and say, hey, what value is this iterator pointing at here? Sure, we could do something like that. Okay, now I know what I'm looking at here. Now I'm going to find the first one that matches if this is true. Gets to be a little funny. That's find. So more often than not, we just, if it's found or not here is great. That's nice for us to know here. This is a big pain just to see if something is found or not here. Be nice if there was an easier way to do it, right? But that's okay. And say was not found is present in the scores vector. And that line. We'll do some more practice with the find ifs on Thursday because this gets to be a lot of fun when we're trying to find with particular formatting functions or whatever the function happens to be here, return true or not, and being able to access an iterator. All right, and then one last one here then, the sort function. So sort comes from algorithm, and we can use sort on lots of different STL containers. Not all of them, right? You can't sort sets because they're not sortable. You can't sort maps. Right? There's no order here, but we can sort things that have a sequence, right, where the order matters. So generally our vectors we could sort. So, and you tell it where to sort from using those iterators, the beginning and end iterators. So it's like, okay, let's sort from the beginning to the end. So you can subset it if you want. You can sort just small portions. I don't know why you'd want half a sorted list though. It doesn't seem like it'd be super useful. But you could if you want to, right? If that's what you want to do. So sorting things out is pretty handy. And then the other really fun thing you can do, like we could do a compare if, or the find if, we can give it, here's a particular function that will return true or false. We can sort things with a specific function. So in this case, we can say, hey, let's sort descending here with a descending function that returns if I is greater than j. This will be true. So it sorts things where when this is true, it moves it to the left. So as it goes to the values here, now we are in descending sorted order, which is kind of fun. But other cool ways to sort things, right? Now if we have, say, a bunch of students, I can use sort to sort my students, right? Before, if we had a vector of students, there really was no way to sort them, right? Because how would you sort a student class? There's no like greater than or less than for students, right? We're saying, okay, if we compare by first name and give it a function for how do we compare these things by first name? Where does that function even go? I missed the function? Here it is. So we'll get their first name and compare the first names. Say, okay, which string is less than the other? Or maybe we want to compare by last name, or maybe we want to compare by ID number. So we can write a couple different ways of sorting our students here. This is actually pretty useful. So now I can sort with a custom sort function to compare objects. So if I want to throw a bunch of my instances of a class in a vector and then sort them somehow, I have to tell them how we're going to sort. And that's super handy. So that one's a lot of fun. So we'll do a lot of those practice on Thursday. We'll play with some of these custom functions for finding things and sorting things. That'll give us something to talk about on Thursday. Okay? How you feel? Bunch of new stuff. Lots of new interesting things we can use. They're very specialty types. So if it fits the problem we're solving, it's something we can use. Right? The reason why that's useful, right, is if I want to make sure I have a unique set of items, I could use a set. I don't need to go and find in my vector every single time to see if I found this item or not, if I've already added it. I can use the set because it's built in for me. Right? It won't let me add more than the same thing more than once. That sort of thing here with our set. We never even tried that, did we? So we had our set of names. We'll do names.insert. Let's add Joy again here. All right, so let's do 1, -1. All right, so we're going to insert Joy, and just nothing happens, right? I still have the same number of names here. So I inserted, but it didn't actually give me another entry here, right? So just basically ignores duplicates. That's all. That's kind of fun there. All right. I think we're good for today then. We've got the next project we're working on, right, due next week coming up. The sooner you start it, the sooner you can ask me questions, right? So a week from Thursday, I'll go over the solution. So start it early so you can ask me questions. Happy to help. Again, it's new stuff, that's okay. We're working on it, playing with our inheritance and polymorphism, treating things as their parent class type with our pointers. And it's super fun. The right function will run at runtime with polymorphism. It's really handy. We'll do this a lot with object-oriented programming. Gets to be a lot of fun. Okay? All right, awesome. That's all we got today then. Have a good Tuesday, and I'll see you in lab.